issues, but I hope that I'm not going to have them while I'm presenting, so we will see about that. So, okay, hello everyone, welcome to my presentation. It's so nice to be here in Athens. Today we're going to discuss about hybrid semantic search in Elasticsearch. I will explain what hybrid is, what semantic is, but basically the main idea, the main focus will be to combine meaning with medical rules. We are going to start from, so this presentation follows a narrative from zero to hero. So we're going to start with some completely basic things for most of you probably, such as setting up Elasticsearch, basic Elasticsearch, and then slowly we're going to build it up on developing semantic search, using Elasticsearch, and then combine these two worlds together in a hybrid approach. But we will see that in a bit. But before we begin, some words about me. My name is Markos. I'm a backend developer at IO. It's a digital agency company, mainly in the Benelux region, so Belgium, Luxembourg, and the Netherlands. From Athens, Greece. Again, it's an honor for me to be here in this event, Dev Days in Athens, because I started my career here, so it feels really nice to be here and contribute. But now I'm based in Utrecht, the Netherlands, another lovely city. I highly suggest if you've ever been to the Netherlands to visit this city. It's an amazing city. I love it a lot. But I know that the theme of the next DrupalCon is going to be in Rotterdam. Maybe a fun fact that our mascot, if I pronounce it correctly, Nietzsche, something like that, is originated from Utrecht. So this cartoon, if you have seen this cartoon, it's actually from the Utrecht city. It's just a small fun fact. If you ever visit it, there is also a museum about the mascot, so I think it's a nice stop to go there and have a look. But okay, you're not here for me or the mascot. Let's check the agenda of today. First, we're going to set up Drupal. We're not going to spend a lot of time on that. Then we're going to set up and test Elasticsearch, the basic Elasticsearch. That will be one project. The second one is we are going to describe what semantic is and what embedded and all of this kind of stuff. Then we're going to create a second project. Sorry, first we are going to also deploy and test a model in that second instance. And then in that second Drupal project, we're going to set up and test semantic Elasticsearch on its own. And finally, we're going to combine these two worlds together in this hybrid Elasticsearch. And why we will have two different projects? That's because I would like to, if there's nothing wrong with the demo, we will see about that. I would like to compare the results of the Elasticsearch, the basic Elasticsearch, with the semantic Elasticsearch, and see, okay, what is basically the power of the semantic Elasticsearch in comparison with the basic Elasticsearch. So, first section, simple Elasticsearch. Set up project with DDev. I think most of you are familiar with this. In case you are not, I think there is a session about Drupal in a day that most likely this is going to be explained more thoroughly. But just to set a foundation, we are working with a Drupal 11. Of course, we are installing Drush. We cannot work without Drush. We are installing the site, and then if you want to log in, DDev Drush URL, so you can log into the site. I'm going into basics step by step, and the reason is that, again, it's from zero to hero that everyone can follow. I know that for some of you, this is, 1 + 1 is equals 2. Then we are setting up the website, and the website, the theme of the website is a medical Wikipedia site, and the motivation of this site is to provide reliable and accessible, and the most important part, easy to understand information, medical guidance for the public, for us, because most of the illnesses or medical cases have difficult vocabulary. And the reason for that is the reason for this website, the value that gives this website is to provide an easy access for the users to follow along. The content type that we will use is a medical, it's called medical case, and the most, well, the fields that we care about, it's the title, the subject, the body without a summary. So we are also working with a formatted text, and related medical cases, which related medical cases, think about it as a taxonomy term, a taxonomy reference. But for this purpose, it's just going to be a text field, a plain text field, unlimited text field. The modules that we will use for this demo is admin toolbar extra. For me, I cannot start a project without these two. If I don't see the drop downs in the menu, it's I'm not something goes wrong. The Search API, of course, and the Elasticsearch connector. It's the main modules that we will also be based upon. Also, I'm going to explain a little bit a custom module, because at the moment in the contributed module there isn't, or I haven't found a module that combines that create the bridge between Drupal and Semantic Elasticsearch. I will explain that in a bit in later slides. But also two more modules, well, a package of modules: AI translate, language, content translate. I put some question marks there. Why do we need that? Well, if you read the description of my talk, I said that the content that I'm going to use would be in Dutch, because I had the luck to receive some 500 medical content data in Dutch. But of course, if I did the example in Dutch, for me, I'm not there yet. I think also not for many of you. So we will not be able to follow the examples in that. So I use the AI translate to do a bulk translate from Dutch to English. And here comes the only disclaimer that I want to say, that the content that you will see is AI translated, okay? So it's from Dutch to English. The model that I used was GPT-4o Mini, because it was the cheapest and most effective. But of course, don't take any medical information and medical suggestion from the content that you will see today. It's AI translated, and most likely, well, they might be correct, but it's a big disclaimer because we are talking about medical data. Next, set up Elasticsearch. We are adding the dev Elasticsearch container. And then we are copying the composer Elasticsearch to the ddev. Again, if you want to follow then afterwards, okay, and you want to start from scratch, you can follow these commands. Then a ddev restart, so you can check that, hey, Elasticsearch is working, is there, you can see it. The version that we will use today for the Elasticsearch, the major version is going to be 8.19.14. So we are also changing here the version manually using ddev to force this version. And finally, you do a curl command, so you can see that you are actually the Elasticsearch server leaves it's working in the ddev container. As I said, the module that we'll use is the Elasticsearch connector, but we have three options here. We will use the middle one because, as I said, the major version, the major Elasticsearch version that we will working on is the 8.19, and the middle one is the 8.0 Alpha 6 is the one that supports this Elasticsearch module. So what we have so far, we are in the ddev container, of course. We have the Drupal instance, we have the Elasticsearch, and the module, the Elasticsearch connector with the Search API to do the communication. Now configure Elasticsearch connector. We create a server in the Search API. Tip: in order to see what's the Elasticsearch URL, you can always use the dev status to get the Elasticsearch URL. Fuzziness is disabled, and why is it disabled? So that means no typo tolerance. Because we are working with medical data, if, for example, some user says, okay, cardio, and then he wants to do cardio, she wants to do cardio, and maybe it might give, it will change that to cardiac or something like that. So then it will give false information, and we don't want that. And add an index in the server that you created. So the content that we are targeting is, of course, the medical case content type that we described before. And the language that we target is English. There is also Dutch in my Drupal instance, but of course we are working now only with the English language. So in the end, it's going to show something like this. The fields, the index fields that we have, again, all the types going to be full text because we are talking about natural language. We have two options, either full text or string. I will explain, I will show the comparison in a bit. And the boost, we give higher boost, of course, to the title, the subject, then the related medical data. So if there is any keyword in the title or subject, we will give a higher weight, of course. Full text versus string, as I said here, we have two options in the type, either full text or string. But why do we choose full text in the Elasticsearch? I will start with the string, it's easier to explain. With string is exact matching. So it's a keyword basically. So when we are talking about IDs or tags, enums, it's better to use the string type. But then because we are talking about medical content in general, we use here full text. Because with full text, we can also enable all these processes, the tokenizer, lowercase stemming. It feels more human. It feels more human search to use basically the full text type. And talking about processes, these are all the processes that we are using in this Elasticsearch basic demo. But let's explain what they do also. So the processors, content access, straightforward. If the user has access, you can see the search results. HTML filter, we strip HTML tags. We basically trim the whole the content, so we will not populate any unnecessary signals. Tokenizer, we split the string into individual tokens, so Elasticsearch can understand and search text more effectively. Ignore cases, we lowercase every token, so everything is going to be lowercase. Again, we do that for efficiency, and Elasticsearch is easier for that to basically do the search afterwards in the indexing part. Stop words, we remove some stop words like I, a, the. These stop words do not give a lot of value to the search, to the content, so we remove them. And then stemmer is similar to like synonyms. So it transforms words from, like for example, makes a word from, what's the English word? Let's say this example, having, to have, has, had, they all have the same token, meaning the same token value. So processors in action, if we do a query, so we can see an example. Let's say that we have this query from a user. The patients were having a severe N% chronic headaches. First, we do the HTML filtering, so it transforms the N% to end or the actual symbol. Then we do the tokenizer, so it breaks the part to simple words. Ignore case, it makes everything lowercase, but I think I have made a mistake here because severe should also be lowercase. So imagine severe here would have been also with small letters. Stop words, so we removed words like, here severe, it's correct. There, where, and. So these words do not give us a lot of value. And then stemmer, you can see that the patients becomes patient, severe, severe, headaches, headache. So it's again more easy for Elasticsearch to do the indexing and the search part. So in the end, what we are going to send from the Elasticsearch, from Drupal to Elasticsearch, we are going to send this query. And this query has all the index field with their boost, their values, title, field, subject, And then here the query is the result of all the processors that we explained before. And what is stored in Elastic? Um, First is the document as a JSON, so the actual content. And then here is after the analysis is the inverted index with all the token words, and they are pointing to what node, what document in that particular case um, they are referring to. And that is how Elasticsearch works and how it makes it efficient to search with Elasticsearch. Finally, all of this comes together with a view search page. Finally, for the first part, for the Elasticsearch basic, we create a new view. The view settings for that is the index medical case. Don't create here the content because we want, here you would also have an option for content, but we want to target specifically the index that we created, so the index medical case, because from there is where we will receive all the information, all the data from the Elasticsearch. And then here is where, okay, the fields, for now it's a responsive grid. You will see how it would look also in the demo. There's not a lot of theme in that demo. What is important is the content. And what is important here is the search excerpt, which it's basically what Elasticsearch will return back. So demo time. So here is the simple Elastic. We have set up Elasticsearch. And if we test, like for example, fever, then it's going to return content that has the word fever in it. So it is basically a keyword-based search, okay? So when a user, and here comes the main problem and the main motivation of what we did, was that as a user, if I want to search for a medical situation, for a medical case that I have, most of the times I cannot describe it. And with only keywords on its own, it's not valuable enough for a user. So, and that's why we created we said, okay, let's explore semantic search with Elasticsearch as Elasticsearch can provide that. And we go to the semantic Elasticsearch, the second section. So what is semantic search in this case? With semantic search, we are trying to understand, as I said before, the meaning of the sentence, and not just matching the exact words as we did before. So, for example, one really nice example that I like always to say is, let's compare two queries, like I like to eat apples, and I'm working on an Apple laptop. In this, the first context, we know as humans that the apple, of course, is the fruit, the red fruit, and all the words related to this one is, all the words related to the first sentence will be close to apple, fruit, fruit, red, green, trees. So all of this context is around this first sentence. But on the second one, I'm working on an Apple laptop. We know that here the Apple is the company, or we are talking about the computers. We are talking about PCs. So the context is different based on what the sentence, what is the sentence that we have. What is embedding in VectorDB, the database? An embedding is a numerical representation of data, text, images, audio as a vector. So imagine an array of numbers between -1 to 1. So you will have 0.22, comma 0. Whatever. So this is how we understand, okay, where is the location, where is the meaning of this word. And the vector database is basically a specialized database that is built to store this embedding content. And in order to find this relevance, what I said before about the apple, so I like to eat apple. In order to find this relevance, for example, here we have dog, cat, wolf, and they are all together. They are closely related. It uses an algorithm of fast nearest neighbor search across all of these millions and sometimes even billions of vectors to understand the relevance between its meaning and its word. Now, to create these embedding numbers, we also need a model. So an embedding model is like the brain for translating text, audio, and images into these numerical vectors that I described before. So we have the document. It will first pass through an embedding model, and then with the embedding, it's going to be stored in the vector. Then we'll get the numerical embedding, and then this will be stored in the vector database. Another nice example that I have, I like the drop news. So what do we think about the drop time news? And the other one is I don't like the rainy drops. So the first one we are thinking about, of course, the drop times. We're thinking about Drupal, and because we're Drupal developers, we are happy. About the other one, of course, we are thinking about the weather, and we are thinking about, of course, the rain, the actual rain. And for me, it's also the Netherlands sometimes. So it is true. But okay, I should not say a lot because the last 3 months were fine. So let's keep it like that. Okay, so set up Elastic and Kibana. By the way, Kibana, you could also install it and set it up before. So you don't. It's not that you only need Kibana for this one, because Kibana is basically a web-based user interface where you can interact with Elasticsearch in a nice way. We follow the same steps as we did before with the basic Elastic configuration, except for the installing and setting up Elasticsearch with the versioning, etc. But here the Elasticsearch configuration are going to be a bit different. Add and configure Kibana, as I said before. And then we do a manual change in the Kibana version to the 8.19.14, which is the Elasticsearch version that we are using in this demo. Then the dev restart so that the changes are there. Now, this is also quite interesting. So in the first is the composer file of the Elasticsearch, the basic one. And then the second one is the Elasticsearch Docker compose for the semantic. We added some things here. But I'm going to break it into 3 parts. The first one is more resources. We are talking about ML, machine learning, and semantic search with models. We just need more resources to our DDev container. Secondly is we want to enable the license. So Elasticsearch has a free trial 30 days license that you can use with the semantic search. But what I found, if I'm working on local dev, I can just restart the license without any issues. So you can, if you are testing and if you are working locally, you can work with that. But of course, if you go to test, acceptance, production, it's not going to work there. So the one is resources, enabling the license, and the other one is the security enable, the XPack security. We set that to false because as when we were working with this one, we found some issues and it was quite difficult. We always had to authenticate. It's just for a good it's just for a good developer experience to disable the security. I mean, you're not going to hurt your PC, so. Then install and deploy a model. The model that we are going to use is the multilingual in5 small. We can run this curl command to the Elasticsearch, and it will take a little bit of time. But the multilingual one that we use, the E5 small, my team said that it's the research that we did was that it's quite useful for the Dutch language, but I haven't tried it a lot. I did, of course, while I was preparing for the English one, but they say, of course, okay, because of its multilingual text, it also is. It can also be quite good also with the English language, from what I have seen. So yeah, we run this curl command, and then we will have the model that we discussed before to our DDev container. And we said that we need the model, so then we can do the embedding translation. So Kibana demo time. I'm going to click the swap display this time. Yes. Okay. So now in Kibana, we have, as I said, we have installed the Drupal Elasticsearch. You can see it in the app/ml overview. with all the related information about that model. You can see the allocated trained model over here. And in order to see if it works, let's run a simple test in the dev tools of Elastic. Again, it's quite nice that with Kibana we can interact with Elastic like that. So first we create a test semantic document. We add here our index. We add here 3 documents: influenza cause fever, the best chocolate cake recipe uses that's cocoa powder, common cold symptoms includes runny nose and sneezing. And then we want to test, check if indeed the content is there, and we have the content in our Elasticsearch. And now what we want to search is what are the flu symptoms. Based on this content, we are expecting to not get the best chocolate in first. That's for sure. If we get the best chocolate first, the semantic did not work. So if we run that, indeed we get the best chocolate at the end with all the related score. Which, by the way, it's also nice to explain here that this score is not how related it is. So the 93 here is, it's not that this one is 93% closer to what are flu symptoms, but it's just a ranking system. Okay, so because if we see here that best chocolate cake recipe has an 86, doesn't mean that the what are flu symptoms is 86% closer to closer in terms of relevance to the best chocolate cake recipe. It's just a ranking way. When we will have more documents, 500, 1,000, a million, then this will be way down. Apologies for that. Then that was a Kibana demo time. And now we have created a custom hybrid module. As I said, this hybrid Elasticsearch custom module makes Elasticsearch semantic search usable from Drupal. Because at the moment, Search API plus Elasticsearch connector have no concept of embedding vectors or semantic text, so we do that on our own. And the hybrid Elasticsearch module, this custom module, extends the Elasticsearch connector module and lets Drupal index content as embedding, which now you might ask, okay, can we find this module somewhere? I'm going to have at the end a GitHub repo where I will publish it. It's not there yet because I wanted to do some alteration, but I will share the GitHub repo with you. And then you can also have a look, and maybe you can also use it in your projects. And also, this custom module provides a truly admin form UI for editors and researchers to basically fine-tune the Elasticsearch semantic weights, values, and don't ask us all the time, okay, let's change this one. We can just expose them there, and then they can easily change the values for their research studies. And now how we are going to configure this Elasticsearch, the semantic search one, not the basic. In the Search API, we create a new server and an index, as we did before. Target is the medical case content type, and only for English. But now it's important, due to this custom module, to enable the semantic search checkbox for that new index that's provided by this custom module, so that we know that the results that we will get from this one are going to be related with the semantic search of Elastic. And then finally, we create a view page similar to as we did before, but we are not going to use search excerpt body this time. So this is how it looks now in the field. I'm going to start with the bottom. We have the 4 fields as you know, the subject, title, with the related boost. But now you might ask, okay, why do we have boost now? Because we are not searching based on keywords, but based on the context. That will come later, because they are going to combine together. And the type is this hybrid full text that is also provided by this custom module. That basically makes it understand that, okay, these values are going to be then merged into this hybrid search virtual kind of field, because this is what we are going to send at the end in the hybrid search in the Elasticsearch semantic server. So this field on top has all the content combined, fine-tuned from the contents below. And the processors this time only has the semantic query preprocessors, and we enable the fields that we want basically to combine to this new virtual field that we will send. Now configuring the hybrid Elasticsearch module, I'm going to also show to you the hybrid Elastic module configuration to you. We have the stop words, synonyms. So in a way, we are creating from scratch all the processors that we used before for the Elasticsearch basic. But now we are developing them on our own because we want to fine-tune them. So we add the stop words, we add the synonyms. Synonyms would be similar to the stemmer that we said before. So fever will be similar to temperature, pyrexia. And these tokens will become equivalent. Then we force lowercase. And another thing that we are adding in this custom module is the globally semantic search. And why we add that? Maybe you have as a fallback the basic semantic search that we discussed before. If something goes wrong with the semantic search, you can just, the editors or us, we can just disable it, and then it can fall back to the basic Elasticsearch if something goes wrong with the model or with the training, or basically the results are not the ones that we are expecting. Again, demo time. Okay. Then here we have, well, let's close this Kibana, we don't need them now. I'm gonna leave this one because this is interesting also. So what I have here, I said I have this virus that was originated in the forest of Uganda. I don't know what's the name. I don't know what's the fever. I don't know what's the virus itself. But I know that was from there. And if I search it, indeed, I will get the Zika fever. So, and no content from here, no Uganda, nothing is basically in this in the key value. So it just understand that okay, it's this one. It talks about this fever. But let's close this one. So here we have the semantic elastic. Here we have the simple elastic with the keyword. If I write here, I like to eat sugar, I will get results about diabetes, overweight. Well, I guess it's logical. But if I do it on the other one, I'm getting the results. No, I don't actually. I like to eat sugar. No, I don't get any results about diabetes. I'm getting different kind of results because it searches based on keywords, and maybe the first one has the eaten sugar, so it gives a lot of value. But maybe it was described due to, I don't know, maybe a story of that content or whatever. But it's not related. I have stopped eating and drinking. Yeah, maybe it can be related, but I think the results of this one are much more close to what we are doing. Show you also the module. So here is the module basically. We have the enable semantic search, as I said, enable. We have here the synonyms that we describe, the stop words, all of that are now done customly, so we build our own processors for this one. Force lowercase, and now we are only working with semantic only, so nothing related with keywords so far. It's only semantic, the search that we are doing. And something to prove that it's only semantic, in the debug, we can see only this hybrid search semantic text that I told you before, this field, this virtual field. And it doesn't have anything else related with the keywords. And now, we are going to combine both of them. And how are we going to do that? Let me do the demo here, because if I do this back and forth again, it's going to be probably problematic. Let's disable this one, save configuration. So now what I disabled was the semantic. Now it does both keyword search with using the BM25. BM25 is, I think, an algorithm that basically gives the score how related a keyword is, if it's matching or not. And now with the semantic search, we also get a score from that side. And both of them are combined with using the RRF algorithm. It combines the one score together with the other score and gives the final results, basically combining the keywords score together with the semantic search score. And we can see that in the debugger, that right now we do see the where is it? Yeah, here we do see the keywords. This is just a default query, and here is a hybrid search semantic. And here we see all the boosts that we described before. And I said, okay, but why are we using the boost? We use the boost for the keyword side. And then we get the score from the keyword, we get the score from the semantic, RRF, and they give us the final results. And now, if I search, I like to eat sugar. I get again all the, what was it? Yes, I like to eat sugar. No, I think I have to index it now. 1 second. Okay, now I get different results. I also get my child is overweight because right now basically it combines, and also the diabetes content that we also got before, because right now we want to get a combination of both of these good worlds of keyword search and semantic search. Okay, and then as I said, we have the hybrid search. We combined the best of these both worlds, meaning with keyword search. BM25 plus semantic fused with RRF, we get the hybrid. What that is, the best match 25 is the classic keyword ranking algorithm used by Elasticsearch for the full text search that we used before. And the RFF is the algorithm that basically fuses these two ranks together. The best match 25 also goes through a normalizer because their number is 10, 20, 50, while the other one is from 0 to 1. So also there needs to be a normalizer for this one to fuse them together. Yes, and now it was the demo that I did before, but we can skip that. And basically, this is the full context of what we did so far. So first, this is the indexing part. Drupal, medical case, the content, we save it. It goes through the search API, the Elasticsearch connector, and this custom module, the custom module that we built, and then it indexes the document into the analyzer. The first part, the keyword part, goes through the analyzer, the tokenizer, stemming, etc. And then this is stored as an inverted index, the regular Elasticsearch part that we know. And then the second one is the model. It goes to the multilingual model. It creates the vector, the dense vector, and this is stored on the Drupal site. And then here on the right, when we do the query, it follows a similar process, but at the end we also have the RRF fusion that combines the two scores, the KNN search in vector with the cosine scores that was between 0 and 1, and then the BM25 score. It gets the ranked results that we also saw before in the Kibana content, the Kibana interface, and then we go back to the Drupal view. So where are we now? User can now more easily find relevant results related to their medical cases. At a later stage, we would like to explore the multilingual, the large one. So far, we are happy with the small one, but maybe we might get better results with the large one. For example, there is one scenario where users are searching just with their medicine, but they don't know exactly what they have, so they just search the medicine, and then the model needs to understand that this medicine is related with this medical case content. So right now it cannot do that, but we hope with the E5 large can further improve the search quality. Client is happy, of course. And then maybe improve, right now, as I said, it's in Dutch, maybe we can do that in the English language. And finally, I'm inviting you to explore maybe the journey ends now with the semantic search and the hybrid search approach, but with this new module, maybe this new custom module, maybe you can also explore this new feature in your own project, trying to search and trying to embed semantic search in your projects. So that was it. Thank you so much for listening and for being here, and always feel free to reach out. This is the GitHub one that, please save that. It's not there yet, but I promise that the custom module is going to, the hybrid Elasticsearch module is going to be there. Thank you so much. Any questions? Yeah.
Hello, thanks for the presentation. Sorry if I missed that because I was a bit late. Did you evaluate similar solutions and decided to use Elasticsearch? I mean, Solar and some more vector-based
More sophisticated
search.
Thing is that one of our team, we did that with a collaboration with the Eindhoven campus, so the Utrecht campus, the one office together with the other one, and they gave us the researchers there. They said that the Elasticsearch is going to be the way to go for your problem. What we did was mainly the translation, creating basically the custom module between the Elasticsearch, but asking specifically why and if they had like a thesis report for this one. Personally, I didn't read it or they didn't share it, but they said that this is the way to go. But it's a good one because indeed maybe there are better options to give us better results for what we are asking. Maybe there's a model specifically for medical cases, for example, or yes.
Sorry, two questions.
Yes.
First of all, for that kind of content, have you tried graph rag logic? Because I think it could be interesting if you make a graph regarding the topics, the medicine, the symptoms.
Yeah.
And I think
Everything
out of the box it could be increase the
accuracy of,
yes, exactly.
of this one. To be honest, everything the heavy load is done by Elasticsearch in this model, so it's a bit of a black box for us.
Yeah.
But maybe this can be, because that was also the invitation for me at the end. If you have worked with something similar, we would be more than happy to also discuss similar solutions. But you said about the graph to.
I think graph it's a nice use case to use graph.
Would be, yeah.
Sometimes we overuse graph, but this is the case that you have to try.
Yeah, yeah.
And the second question is, if you at the end don't use the key value for Elasticsearch, the Elasticsearch and you use only
semantic.
Yeah, it's actually like you using Elasticsearch as a RAG.
As a RAG, yeah,
Okay.
exactly.
And
but we use the keywords. We want to use the keywords because that's something very important that I missed. The researchers and the editors, the doctors, they want sometimes to force some keywords results.
Yeah.
So if they know that, okay, with the semantic it can go completely random and we don't know the result, the researchers and the doctors that are using the website, they would like to force these keywords and this content for a particular scenario. Like, for example, the one that I said with the medicine.
Yeah.
There is a medicine name, semantic doesn't know it. So with the keyword, it forces us to, okay, go there.
Okay, sorry, but just thinking loudly. In that case, you can extract that key values that you want to filter the content in the RAG. So you can filter first with that key values and then make the rest of the search based on sematology.
Sematology, yeah.
Anyway, we can discuss further.
Yeah, maybe, yeah.
Thanks for the presentation. So I would like to ask, it's not clear where are the vectors stored. So do you use a separate database? Are the vectors stored directly in Elasticsearch?
They are stored in Elasticsearch, yeah.
Okay.
They are stored the embedding, and the model that we are using translates the content, the text to these embedding values, and this is indeed stored in the Elasticsearch.
Okay, thank you.
Maybe if I here, for example, here it's stored. Where is it? In the save, we are in the Elasticsearch phase, and then after the model, it's stored in the dense vector of inside the Elasticsearch ecosystem.
We can have 2 more questions to keep up with schedule.
Hello.
Hello.
The first gentleman mentioned about GraphRag, and basically this is the issue that you spotted while searching via medication. Basically, you're polluting the vector space by having information about the patient, information about the disease, and information about the medication. So if you split them and have like chunking, have 3 different chunks related to this node, you will get better results. So
thank you so much.
And you don't need a graph rack. So that's
and then I don't need, sorry, the graph.
yeah, you can do it in the last.
Maybe I can use like that. Thanks for the tip.
Hi.
Hi.
Thanks for the presentation. Nice work. Couple of questions into one, so we don't count this as 2 questions. Have you considered, because we see a growing like solutions in AI search and like kind of reply with human language, natural language, and the good thing is the vector database is kind of already a good requirement for AI kind of search. Is this first of all a consideration for a future kind of not improvement, like version or application where you could have natural language results based on your database?
Now the thing is, because that's another thing, because we are talking with
use case, I guess.
because we're talking about also a healthcare provider that it's in the public sector. Still, they are a bit slow with this one, and they want to do it step by step. So I think this one is the first approach. They see that they are happy with what AI and what semantic search can do in this case. So then maybe they can, we can maybe have like a second, like another option to maybe go into this this direction.
Okay. And the rest of the question is mainly how do you review this? Because search is very tricky to get to like a benchmark of this is what we need. Like a user would, I don't know, complain that like I was expecting something different. Or as you said, you had a stakeholder that considers something more important to show up as a result. What's the workflow there in terms of manual or automated testing plus user feedback or stakeholders feedback?
And that's a great question also. It is done on the healthcare side. So they basically do that. That's why the main part of this presentation, the module, is to provide the translation and the connection between the Elasticsearch semantic part together with Drupal. And between these two, they can do that's why we allow them to do the fine tuning. So, because in the beginning they say, okay, do these changes in the values, etc. And by exposing them, they can just test it on their own in the acceptance environment with their own data. But personally, as a backend developer, I don't know exactly all of the.
I see.
Yes, thank you so much. Ευχαριστώ πολύ.
Όχι, το έχουμε επενεργοποιήσει γιατί συνήθως το αφήνουμε.
Και 1-2.
Και τεστ έχει, κάντο και κάντο εσύ. Αυτό που βλέπω.
Ένα.
Δεν έχει
φορά το κόκκινο κουμπάκι και για να φύγει. Αυτό.